My name is Jun Pei. I'm the co-founder and CEO of Cepton Technologies, which is a company located in Silicon Valley. This is a company a couple co-founders and myself included started 2016. And like many entrepreneurs in this Silicon Valley, we aimed of doing something that's useful for the society. And specifically, we actually worked in the field of LiDAR. LiDAR is not a very common word in the industry, but it's becoming more and more popular, given its reach in autonomous vehicles. So it is a device that can measure the three-dimensional environment, and that's what LiDAR does, and it was considered earlier on as an enabler for autonomous vehicles, and now it's becoming popular as a safety device for everyday cars. That's what we work on. We founded the company on having an innovative approach of doing LiDAR, and together with quite a few notable technologists, we anchored our place in this industry. So that's us. We make LiDAR in Silicon Valley. We actually, like I said earlier, we make LiDAR. It's a automotive component. That it's a new component that doesn't exist on cars these days. Your car has a lot of cameras, maybe a dozen cameras looking at the front, looking at the back, and does a lot of things. But LiDAR is this new, what we call three-dimensional camera that actually is going to I'm a firm believer that's going to be as popular as cameras in the future, so that you actually have a capability of observing obstacles in three-dimensional way, not only where it is at, but how far it is and how big it is, so that you know whether the car should or should not continue to go. So that's the product that we're making. Using LiDAR itself is not unique. It actually started in 2005 when there was the Department of Energy, DARPA, had a grand challenge autonomous vehicle competition, and it was that time that LiDAR started to come into picture. Actually, one of the companies that actually championed the LiDAR technology was called Velodyne. And I just happened to know the founder of Velodyne, through some hobbyist activities, and again, long story short, is I actually joined Velodyne and worked for him for a few years before I started my own company doing optical instrument. So I had my background in LiDAR, so I kind of know what I was entering into. And by the time 2015, 2016, the autonomous competition was way behind, but the true autonomous vehicles was really in fashion. And you probably know, at the time, whether it's Google, Waymo, Baidu, all the big name companies would have a autonomous vehicle research branch, and LiDAR was this key instrument, the eyes for the vehicle. That's how I thought, hey, it'd be good to pick up something that I did in the past and make something new about it. And that's, that was the background. LiDAR is a system. It's not a single material that you create and you can massively produce it. It involves fundamentally the optical system, the electrical system, precision mechanical system, as well as tons of software firmware control to make the system working. So it's a rather complex system. And I just so happened to have some expertise in each and every one of them. Obviously, I had my PhD in optical engineering, so that was the forefront. So it actually, your so-called research and development, it goes really into two extremes, and maybe start with more of a glorious aspect of doing R&D. That is, I get to read papers, I get to read journals, and I actually understand what optical capabilities or components or technology available outside the world, where it's applicable or not applicable to our own application. I would read it. I would actually try to understand, and sometimes I would order some samples so that we can do some R&D testing. So that would be the glorious part. But then we are a company. We're a for-profit company. We make product, and I would say, to make a product, the R&D part is probably 1%, inspiration. You have a great idea, and then the rest of it is all the grunt work and making a product and debug it. It's like, okay, I have this great idea. I want to write a program to do a Fourier transform. Great. Then the algorithm part, it takes you 5 minutes to understand, but you probably need an hour or 2 hours, maybe 5 hours to actually put the code together and debug it and actually make it work. So my R&D work is very much like that. Very small amount of time is spent on the inspirational, truly glorious R&D idea type of generation, and the rest of it is, hey, why is this circuit not working? Why is the optical path has extra straight light that I have to kill? So things of that nature is more. It occupies most of the time, and actually it's true not only for me, for most of R&D engineers. It's like that. This is when I was in school, and when I write an essay, the professor would always tell me, whenever you write something, you need to keep your audience in mind. Who are you talking to? You got to use their language to communicate. So it's very similar in product making. There is a huge customer aspect of your product. Eventually this, however lovely this baby creation you have, it has to go to a customer and see the real world. So ease of use by the customer is certainly one aspect of things, but there are many. Whether it's the performance meets up the expectation, the cost is low enough for them to afford it. All of these aspects, the customer aspect has to be part of your design in the spirit from the very beginning. Before even you have a draft, before even you have an invention, you have to have the customer thoughts in mind that is something that's going to be good for the marketplace. Can also equate that to something like playing chess. You make moves in the chess game, and sometimes there's very easy moves, very obvious moves. Sometimes it's very tricky and hard moves. You have to make calculations, balancing the power, and make decisions and take risks. So all of these factors are going to be just like you're debugging one bug at a time. And each move, especially the important ones, would actually teach you something, and that's a learning for life. My current day at work is basically more or less stuck in the office or conference rooms. So I start obviously in the morning, and usually East Coast it's already rise and shine at your clock. So I talk with the investors, I talk with the Wall Street connections to make sure our messages as a public company gets through. And then there's I came from an engineering background. I continue to be an engineer. So as the engineers usually start to work a little late in the morning, and I start to get involved in a lot of design reviews. And then usually I host a lunch meeting of various capacities. Sometimes it's the senior staff meeting. Sometimes it's just a junior level technicians having my office hours with them. And then in the afternoon, I would actually reserve a couple hours doing some technical research and reading, followed by even more meetings before the end of the day. Most of the time at home in the evening, I would actually chip in another couple hours to just to catch up on some miscellaneous stuff. So that's my current normal working days. But just to go extreme, 7 years ago when I started the company, we had only 5 people as a startup company. So my day would actually start fairly early in the morning. My first job description is actually a janitor. So I clean up the office for about 10-15 minutes and then go right into the lab. I would actually spend the entire morning into the lab until lunchtime, where I have a break. And usually in the afternoon, I would sit at my desk and do more designs. So it's experiment and then design, experiment, design. So morning is in the lab, and afternoon mostly at my desk doing calculations and design work. And probably the entire evening is also in the lab. So I would have all 3 meals in the office. So that was more of a kind of a real, true spirited startup environment, and it was a very far cry from what I have today. You remind me of a very small story I had with a very notable professor. His name was Kelvin Quate. Professor Quate was the inventor of acoustic microscope at Stanford Kingston lab, and I didn't work under his lab. I worked in the lab that's next door to Professor Quate, but he was so well known. He was a recipient of Freedom Medal from President George Bush, the senior George Bush, actually. So one day I thought about something. I don't even remember what I thought of, but I went to his office. He was a very likable person, very gentle to students, and I told him, hey, Professor Quate, I got this great idea I'd like to talk with you about. And then he raised his head, looked at me, he said, young man, ideas are cheap. I want to see results. So that's actually, the story I wanted to share here when you ask about creativity and the innovation spirit and all of these things. Is ideas are cheap. It's the result that counts. And as I have mentioned a little earlier, the R&D work that we usually do have maybe a fraction of a percent time that's more uplifting spiritual ideas comes into play. But does that work or not? Is the 99% of the grunt work that you have to make sure that it actually worth anything? So the creativity is certainly you should keep your natural curiosity of things, and you always have ideas. All of those are good, but never forget, ideas are cheap. It's the result that counts. You should never lose your interest in embarking on some challenging journey and solve some difficult bugs. So I actually don't have an answer on how you would keep up your interest, because I've witnessed enough people to eventually get a burnout when things gets really tough. But keep your natural interest is actually almost as critical as actually practice your debugging capabilities.